Dear students, under the topic Laplace transform and inverse Laplace transform, we are solving problems under ordinary differential equations. Now we are going to solve the given ordinary differential equation by using Laplace transform. First of all, we have to rewrite this equation. We know that d squared y by dt squared is the double differentiation of the variable y. So it can be written as y double dash minus dy by dt is the first differentiation of y with respect to t, and so it can be written as y dash minus 2y is equal to 0. And these conditions are known as the initial conditions, where it is given that y of 0 is equal to minus 2 and y dash of 0 is equal to 5. So now, first of all, we have to take Laplace transform on both the sides of this equation. So we will be getting Laplace transform of y double dash minus Laplace transform of y dash minus this two constant can be taken out, and Laplace transform of y is equal to 0. Now by the formula of Laplace transform, we know that Laplace transform of y double dash is equal to s squared L of y minus sy of 0 minus y dash of 0. And Laplace transform of y dash is equal to s multiplied with L of y minus y of 0. So now let us apply this formula in this equation. So instead of Laplace transform of y double dash, we can write it as s squared L of y minus s multiplied with y of 0 minus y dash of 0, and then minus of Laplace transform of y dash can be written as s into L of y minus y of 0, and then we have minus 2 Laplace transform of y is equal to 0. Now s squared L of y minus s multiplied with what is y of 0. From the question it is given as minus 2. So let us substitute that. So minus 2 minus y dash of 0. So from the question it is given as 5. Because y dash of 0 is given as 5, we have to write 5 over here. Minus s into L of y. And then minus into minus is plus. But what is y of 0? It is minus 2. So we have to write minus 2. Minus 2 into L of y is equal to 0. So now on rewriting, we can see that L of y is common in this term, and this term as well. So if we take L of y common in these three terms, we will be having s squared minus s and then minus 2 multiplied with L of y. And then what are the remaining terms? Minus into minus will become plus 2s. And then the other remaining terms are minus 5, minus 2, which will become minus 7. And that is equal to 0. Now let us take this 2s minus 7 to the right. So we will have s squared minus s minus 2 multiplied with L of y to be equal to, when this 2s goes to the right, it becomes negative, and this negative 7 when goes to the right, it becomes positive. So it will be 7 minus 2s. Now we have to take this term to the right. So your L of y will be equal to 7 minus 2s divided by s squared minus s minus 2. Now let us try to factorize the denominator. So what is the denominator? S squared minus s minus 2. Now if we want to factorize, we have to use Hill method. So minus 2 multiplied with the coefficient of s squared, which is 1. So we have to find the factors for minus 2 in such a manner that the factors when added up should give the coefficient of s, that is minus 1. So if you see 2 1 times is 2, and we want a negative sign, and here we have a negative sign. So let us give the negative sign to the bigger number. So the factors are minus 2 and 1, and so the factors of s squared minus s minus 2 will be s minus 2 multiplied with s, and this is plus 1. So s plus 1. So therefore L of y is equal to 7 minus 2s divided by, writing the factors of this, the denominator becomes s minus 2 multiplied with s plus 1. We have to find the solution, which is y. So y will be equal to, taking this Laplace transform to the right, it will become the inverse Laplace transform. And so y will be equal to Laplace inverse of 7 minus 2s divided by s minus 2 into s plus 1. So now let us mark this as equation 1. And whatever is in the bracket, we will evaluate separately. That is, we want to find what is 7 minus 2s divided by s minus 2 multiplied with s plus 1. We have to find this separately and then we shall substitute in this equation 1. Now, in order to evaluate this, we have to separate it by using the partial fraction. Now, since the denominator, these terms are independent of one another, we can easily write them as a divided by s minus 2 plus b divided by s plus 1. Now, on taking the LCM on the right, we will be having a multiplied with, so cross multiply, s plus 1 plus b multiplied with s minus 2. And on the left, we have 7 minus 2s. And the denominators will be same on left and right, so it will get cancelled. So we obtain this. Now in this, we have to find the value of a and the value of b. Now in order to find the value of a, let us put s to be equal to 2. So put s to be equal to 2. So what will happen if you put s as 2? On the left you will have 7 minus 2 multiplied with 2 is equal to a multiplied with s is 2, so 2 plus 1. And if you put s as 2 over here, 2 minus 2 will become 0, and so this complete term becomes 0. And we can easily evaluate the value of a. So this is 2 times 2 is 4 and 7 minus 4 is 3. So 3 is equal to 2 plus 1 is 3. So 3a, from which we obtain the value of a to be equal to 1. Now in order to find the value of b, we have to make a as 0, for which we have to substitute the value of s as minus 1, so that minus 1 plus 1 gives this term to be 0. So therefore we have to put s is equal to minus 1. So on the left we will be having 7 minus 2 multiplied with minus 1 is equal to, so this term becomes 0, and we will be having b multiplied with minus 1 minus 2. And so on the left, 7 minus into minus becomes plus, 2 1 times is 2, so 7 plus 2 will give us 9. That is equal to, on the right, minus 1 minus 2 is minus 3, and so we will be having minus 3b. From this, we obtain the value of b to be equal to minus 9 by 3, and so therefore the value of b will be minus 3. So we have obtained the value of a and the value of b. So therefore we can substitute over here the value of a and the value of b, and hence y will be equal to Laplace inverse of this term, and that was equal to this, and so therefore we can write y to be equal to Laplace inverse of, now this term has been simplified as a by s minus 2. What is a? It is 1. So 1 divided by s minus 2, and then plus b by s plus 1. What is b? B is minus 3. So let us write that minus over here. So 3 divided by s plus 1. Now we have to find the Laplace transform of each of the terms separately. So therefore Laplace transform of 1 by s minus 2 minus 3 is a constant which can be taken out, multiplied with the Laplace transform of, Laplace inverse transform of 1 divided by s plus 1. So next step will be, now we have to apply the Laplace inverse transform formulas over here. The Laplace inverse of 1 by s minus a is equal to e power at. Now here we have Laplace inverse of 1 by s minus 2. The value of a is 2. So it will be e power at. So it will be e power 2t minus this 3. And what is Laplace inverse of 1 by s plus a? Laplace inverse of 1 by s plus a is equal to e power minus at. The value of a is 1 over here, and so we will have e power minus t. So therefore we have obtained the value of y to be e power 2t minus 3 multiplied with e power minus t, which gives us the solution for the given ordinary differential equation. And we have evaluated it by using the Laplace transform. So hope you have understood this problem. Thank you.